welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Phil Tomasello.
Thanks for the introduction, William. Thanks to everyone joining in today for another Tech to Tech. Happy to be here. Glad you could join. Our topic this week is flash rust on ferrous alloys. And we're going to talk about the challenges that you have with rust, the options to protect your substrates from corrosion. And the best way to start is by simply defining what ferrous metals are. And those really are metals that contain iron. They have substrates that are certainly cast iron, wrought iron, many others. But that's really the common denominator, is that there's iron in that substrate. So when iron is exposed to moisture and oxygen, it'll start to corrode. It forms iron oxide, which is generally red in color. That's what we refer to as rust. Flash rust, by definition, is a very rapid corrosion that happens on bare surfaces of ferrous material after washing or media blasting. So you're etching those surfaces. Certainly when water is used as a source, that exacerbates that. High moisture or humidity in the air is a big factor. And when you combine that with heat from the wash process, the cool down period, you're going to see flash rust occur. It can happen within seconds. We've seen that as a very common thing, certainly minutes within hours of the wash process. And very, very common in the later months of the year where humidity is high, summer months, July, August, September. That's typically when we get most of the calls from our customers saying, hey, I'm really seeing a problem here with flash rust. Can you help us? If you don't have environmental controls in your facility, it definitely is a challenge you have to keep up with. I put some images here on the screen, I think, that pretty much explain that, but this is an electrochemical process, right, for metal corrosion. On a molecular level, let's say you've got electrons that transfer from iron molecules to oxygen molecules on your surface, and that composition is what you see, the end result of the red, typically red image there. So every material, important to note, is going to have some corrosion on it, whether it's visible or not. Water, of course, is the accelerator of this. High electrolytes, humidity. If you damage the surface, media blasting is a prime example. You're changing that surface. That's going to increase the rust challenges that you have. So raw materials, water, O2, rust. These three images are examples from real world processes that I've been involved in. And over here, you can see some spotting that starts, some heavier specks that come in. And on this side, this image here is just where you see a big swath, a big spread of corrosion that shows up. In process, if you look at a cabinet spray washer and you look over here, this company is opening the door, and when everything flashes off, the vapor goes. It's almost like a spray can of orange paint on these materials, on these substrates. Hot vapor comes out there. When parts cool, the humidity, high humidity increases. Certainly, there's water vapor in the air. Parts cool, it's attracted to the cold surfaces. That's when you really have the challenge. Again, seconds, minutes, hours, you can see this. There are many key points or ways that you can avoid flash rust on ferrous substrates. First, I think it's important to take a look at the water quality that you have. That has a big impact on that. If you have a lot of salts or mineral content in that water, high chloride, that's a common thing. So untreated water sources, real big factor. And a lot of folks on the metal finishing side of the business often are using local water sources. To give you an example, if you look at folks at home, you have underground sprinkling going on, coming from well water or other water sources. And sometimes you can see that, and there's a discoloration when that hits the sidewalk. That could be salts, mineral content that will show up. Well, that's what you're introducing into your wash bath. And that really is a significant contributor to flash rusting. We like to think about opportunities of using reverse osmosis water to reduce the contents in it, the mineral content, things that are going to contribute to that. So RO water is a really good consideration if you have cleaning specs that you need to meet, and if you're trying to really mitigate the rust issues. Real good start. Some other things. When you have substrates that you're working with and they're clean, best to wear gloves once they're washed. You have salts, you have oils on your hands. If you are touching clean substrates, you are reintroducing some of those contaminants to your substrate, which will contribute to rusting. And it's a common thing if we look at parts that are being cleaned. If they're being picked up with bare hands, you can almost see fingerprints, finger marks on them. Humidity controls. Some facilities have humidity controls in areas where they're doing washing. Others do not. It gets hot, it gets humid in there. They throw up the bay doors to try to ventilate the place. That's not ideal. Again, high humidity, more water vapor in the air, parts start to cool. That water vapor is attracted to it. That can be a challenge. You can also avoid some of the rust issues downstream when you have products coming out of the wash process. If they get to ambient temperature and you can control those environments, it's common for people to throw the very hot parts, maybe being washed at 140, 150 degrees F, say an aqueous process, into VCI bags, vapor corrosion inhibitor bags, very quickly. When they put them in the bags have air, humid air in them. You're attracting parts, the parts start to cool. You're basically creating a rainforest in those bags. So take a look at that. Take a look at your dry process, your dry times. And if you're packing them in BCI paper or bags, do so when they get to ambient temperature after being fully dried in your wash process. Wash, rinse, dry. Corrosion preventatives, right? CP materials, as we call them, in the final stage of a rinse process is really what you're going to need. If you have a standalone dip tank, you can quickly go from wash, carry it over, put it in that dip tank. But ideally, as we found out over the past many years in producing combination chemistries, it's a great idea if you can find a cleaning chemistry that will clean the parts while also providing corrosion preventative benefit on a molecular level. And that's what we refer to as combination chemistries. You're cleaning and you're providing CP all in one. And I'll show you an example of this great illustration coming up in just a moment. But combination chemistries really are a two-in-one that allow you to do both at the same time. You can measure consistently the concentration. In tank one, you've got your wash chemistry. If it's combination chemistry, you don't worry about the drag out into the rinse tank. You only have to measure one chemistry. The carryover is beneficial. You don't have as much dwell time, leading to flash rust if you take it from a specific wash tank and then carry it to a separate dip tank for a corrosion preventative process. That delay can cause flash rust, and that's a common thing that we do see where someone will wash parts, let them sit for 10 or 15 minutes, take a break. By the time they get them to that separate dip tank with CP in it, it's already rusted. Combination chemistries, of course, you only need one product. You don't need a secondary chemistry, which can cause challenges in measurement. Great example right here. This illustrates if you have a wash, rinse, dry process, aqueous, of course, here's the flow. In your wash tank, you've got a chemistry. In traditional process, you would have a wash chemistry. Then let's say in here, you would have in the rinse tank a corrosion preventative. And then, of course, to your dry. So traditional chemistries that aren't combo chemistries, you would be measuring this concentration of your wash, let's say an alkaline process, alkaline material. And in your second one, you would have to measure the corrosion preventative concentration. But that's going to be diluted by the concentration of the wash chemistry. And the majority of those can't be measured in the same process. Conductivity, titration, it's going to be a mess. So you end up really turning over that rinse tank more frequently because it's being contaminated from the wash. That's what happens in standalone chemistry, typical drag out. You can avoid that with combination chemistries in use and mitigate that flash rust. A lot of folks are running many different metals, multi-metals, brass, copper, aluminum, steel. So if you're running ferrous and non-ferrous metals, there are combination chemistries out there that are going to work very, very well with multi-metals. The key is to identify specifically what substrates you're going to be washing in one wash tank or one wash process. There are some chemistries that work very well with some ferrous metals, but not with the softer metals. And so that's really important. So when you look at some considerations in mitigating flash rust, you want to get the best outcomes you can. Ask yourself these questions. Are there other ferrous metals or non-ferrous metals specifically that are being cleaned along with the ferrous metals? If you have ones, which ones are they? Are those metals going to be washed in the same parts washer? Are there upstream process that you have that you know of from your suppliers that you can understand, that you can speak to, that you can question? If you have that upstream process, you can identify if your parts are coming in perhaps with what we would call seeded rust. Seeded rust is essentially rust that you necessarily can't visually identify on a part. Every part has them. The better your upstream supplier is with mitigating that, the better off you're going to be. What's your water source? And what environmental controls do you have? Do you have dehumidification options in your facility? Do you have fans going on? Do you have a water source other than city water that's there? Another thing is identifying what your corrosion requirements are, the CP requirements. If you need corrosion protection for 30 days, 90 days, 60 days, whatever that is, that's going to dictate what materials you're going to be using from a chemistry standpoint to achieve those outcomes. We do this in our lab. Our applications lab does this all the time for customers. We work with simply time, humidity percentage, and temperature. And what you see over here is a standard looking humidity chamber. So we run 90% relative humidity at 90 degrees Fahrenheit, and we approximate a real world condition to try to establish 60 days, 90 days or more corrosion protection based upon what the customer's needs are going to be. 1 day in the chamber really equates to 9 days in the real world. And that'll help you gauge that. So you can then speak to the variables when you're washing: time, energy, solvency, temperature. What's that need to be? And you can fit the best chemistry to your process to get those outcomes. As I just mentioned, these are the 4 key variables that need to be considered for controlling your process and optimizing that process that you have for washing. Time, total exposure, dwell time, impingement time, dry time. The energy, what's that flow look like? What's the amount of PSI do you have for impingement? What's the mechanical energy? Is there ultrasonics being used in your wash? Is it spray and immersion, spray and air? Solvency, what's the chemistry? What's the concentration of that chemistry? And then, of course, temperature, wash, rinse, dry. Temperatures do vary. Most chemistries, certainly KYZEN chemistries, work very well in the range of above 130 degrees F to about 150 F. It's a general range. But again, a lot of it's going to be dependent upon the parts itself. We know that softer metals like temperatures in the 130 range, 135 range. We know that other, let's say, cast iron, steel, certainly 150 is not an uncommon temperature for wash. In managing flash rust, take a look at the ferrous metals you have, control your environment, reduce that humidity that you have. The moisture is going to be reduced significantly. You're going to be able to mitigate some of that. You got to get the right process and the chemistry to match up with the substrates, the soils, and your cleanliness and corrosion preventative expectations. Again, are you running ferrous only? Are you adding some non-ferrous parts? Do you need 30 days, 60 days, 90 days corrosion protection of the soils? polar, non-polar? Is it only greases and coolants that you're cleaning off? Those are considerations that really will help allow you to work backwards from the data and the challenges to find that solution. Make sure that when you're cleaning parts, you get the proper corrosion preventative material on them, and package these things again in bags, VCI bags, after fully cleaning them. Make sure they're fully cleaned, fully dried, and at the right temperature so that you can do that without adding to the challenges of flash rust that we mentioned earlier. This is an important point. This comes up a lot. Rust is not contagious. So a lot of people will say, hey, I have a rusted part. I don't want to leave it next to another part. That'll transfer the rust to that part. That's really not the case. It's not going to spread from one part to another. Rust doesn't do that. It really has to do with the environmental conditions that you have. That's what's going to make rust occur, flash rust occur over multiple parts. So the individual properties of each substrate have an impact on that as well, but you're not going to transfer rust from one part to another if you have it in the same location. With all that said, there's some frequently asked questions that we get that I'd like to work through with you just briefly. A lot of people ask, if flash rust, how can we just prevent that? And the answer is that you can't completely prevent flash rusting. You can help lessen that by working through the process, managing your environmental conditions, taking a look at the upstream process with the substrates that are coming into you to make sure there's not a lot of rust on them to begin with. And then you can speak to that with different cleaning processes to clean that surface, then move to the next. So not completely preventable, but if you have a good process in place, you can significantly reduce the flash rust you're getting. Another question is, hey, what corrosion preventative products can work best for me? And that really comes down to examining your soils, your substrates, your cleanliness, and corrosion preventative expectations, and then speaking to your trusted chem provider and working with the applications and analytics lab. We can really work backwards from the challenge, from those expectations, then we go back, we can find that solution for you. But paging through a chemistry catalog is not a great way, of course, to find your best solution. Combination chemistries, can they save me time and money? They can. Typically, a combination chemistry, there's much more dedication and technology to building them. They're not always the least expensive solution for the chemistry itself, but you're saving time, you're saving money in rework because you're mitigating that flash rust from one process. You've got one material to measure in the wash tank, carrying over into the rinse tank. In a general example, let's say in your wash tank to tank process, you would go from maybe a 10% wash chemistry. Your rinse, you might set at 3%. It's the same chemistry. So more carryover is not going to dilute that rinse. It's going to really help maintain a good balance for you by the time it goes down to the dry process. So it will save you time in rework. It's going to save you time in trying to measure separate chemistries that you might have a wash and rinse, two different processes of measurement. All those things add up. Final question really is, how can I determine if a combination chemistry is the best one for my application? And again, talk to your chemistry provider, and the chemistry providers with the sophisticated applications and analytics lab will be able to guide you to find out whether that fits your need or not. So people at KYZEN, happy to have that discussion with you and your team. Just give us a call and we can answer those questions for you. I hope this was a beneficial tech to tech for everyone. I hope everybody enjoyed that and got something positive out of it. With the summer months coming rather quickly, I would argue this would be a good tech to tech to bookmark and reference in the months of June, July, August, and September. Thank you very much. I appreciate you tuning in.
Thanks, Bill. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@KYZEN.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.